I'm going to talk to you about a few points that you need to look at before mapping any field. Now, when assessing the field condition, the first thing we need to check is soil moisture. That can be done with a soil probe. If the soil probe can penetrate the soil and collect a soil sample, then there is adequate moisture to map EC. Next thing I want to talk to you about is frost. A lot of guys deal with this in early spring and late fall, you know, after crops have either come off or before crops go on. And frost is a kind of a danger zone for mapping. It actually can inhibit EC signals going into the soil, and we just tend to steer away from them for data quality purposes. Another thing you need to look at is uniform field condition. Now, this relates to tillage practices, different types of crops, and also different irrigation practices. All three of these things will directly affect the EC values and also affect the overall data quality of the mapping that you collect. Now, here I have an example of a map that was generated in the field contain different field conditions or different practices as far as tillage or irrigation. This particular one, the whole southern end was actually a very high state and the northern end was very low. And down here it's split almost in the middle. And this is exactly what we want to steer away from, and this is why you need to assess field conditions to make a good data quality set. Alright, now before we get mapping, we actually need to verify a few things. Right now the implement is raised out of the ground and we are seeing a -1 values. Now the -1 values indicate that we are not making good soil contact, and that's actually a good thing. Anytime there's -1 lifted out of the ground, that means the system's operating correctly. Now as soon as we place it in the ground, the values actually start to show, you know, whatever the EC is of the soil we're in right now. Alright, and right now the data status lights actually appear green. Now we want to see green, and that means the data is being sent, and then on the data logger it's being logged. Both of these indicate that we're saving the SD card and that we're creating a good data set. One other thing that I want to talk about while you're actually mapping, you need to assess that the data values you're seeing are accurate to the soil types you're in. Sandier soils will have lower EC readings, and the clays and heavy silt loams will have higher EC readings, and salinity will have EC readings that are extremely high. Now all of this is just tips to help you collect data when you're out in the field. If any of the things I've talked about aren't occurring for you, then you may need to visit the troubleshooting section in your manual. Before going to the field and mapping, I want to give you a few pointers on how to collect good EC data. First off, we want to talk about swath width. Now typically we run on a 50 to 75 foot swath, and here is a map that has been generated on 60 foot swath width. Now this is a high density, or a high enough density, so we can collect good data, and we can also see the zones starting to form in the raw data. Next thing we want to be mindful of while we're mapping in a field is any previous field operations that could have left very heavy trafficked wheel tracks, and also any strips of very heavy residue that could have been left over by combines. Now these, you can shift over your swath just enough, because it's more important to collect good data than to have an exact swath width. Now we want to make sure that when we're running and collecting EC data that we have the coulter discs about 1 to 2 inches in the ground. So as we lower in this ground, we'll actually start to see soil penetration. Now the soil penetration needs to be, like I said, 1 to 2 inches, and this will actually be evident in the EC controller in the cab. And what we want to see disappear is the -1s. Now -1s correlate to when the implement itself is out of the ground, and so we just want enough penetration to allow the -1s to go away. The speed that you collect an EC map directly affects the EC data, and what we want to do is run 8 to 12 miles an hour and make sure we have good connection to the field. Now once you're done collecting the EC data in the field, we want you to look at the raw data and review it for spatial structure and also pass-to-pass repeatability. Now this map right here shows both. It has good spatial structure, and the pass-to-pass repeatability is very relevant. Now if you look at this next map, we had probably intermittent connection on this field, and also we're missing chunks of the field, and the pass-to-pass repeatability is non-existent. At this field, we had moisture conditions. This field, the deep was not taking a correct EC reading, and the shallow wasn't making a very good spatial structure as well. Now, if either of these cases are present with your data, then you need to review all of the other tips that we've given you as far as implement troubleshooting and also data troubleshooting.